Good evening. Thank you for joining us. Today, on Biochemistry Now, we'll be examining a study first conducted by Carolyn Fitch and Bertrand Garcia Moreno, Johns Hopkins University, as well as Gerald Platzer, Mark Akron, Lawrence McIntosh of British Columbia University. Their study was titled Arginine, its pKa value revisited. Historically, the pKa value of arginine and lysine has been reported to be in the range of 12.2 and 12.5. Given these pKa values, it would be expected that the guanidinium group and the side chain aminium group of their respective residues would be deprotonated inside hydrophobic environments. Lysine, in fact, does follow this generalization. When we see it in hydrophobic environments and hydrophobic domains of proteins, we find that this side chain aminium group is found as a neutral species. Arginine, however, does not fit this mold. When we observe it under physiological pH in proteins with hydrophobic environments, we always observe it to retain the positive charge. And this leads to an apparent contradiction. If we're saying that its pKa value should be between 12.2 and 12.5, in fact, the guanidinium groups should become neutral species. So, what are the reasons that could account for this apparent contradiction? There's three main ones that we're going to address. The first one lies in the guanidinium group. The guanidinium group is a central carbon with three surrounding amino groups, all sharing partial double bonds. In the arginine side chain, this guanidinium group allows for a delocalization of the positive charge. By delocalizing this positive charge, it minimizes the unfavorable interactions inside the hydrophobic environment. It also results in a lower hydration energy. Therefore, in hydrophobic environments, the guanidinium group resists the urge to dehydrate, and therefore it retains the proton and retains the positive charge. The second reason for this is the flexibility of the arginine side chain. Arginine side chain is relatively long, and the guanidinium group is planar and is able to flex back and forth. This enables arginine to seek out polar solutions as well as other polar residues that may be located in other areas of the protein and to satisfy its hydrogen bonds. Therefore, the flexibility could account for why we never find arginine as a neutral species in hydrophobic environments. And the third reason is the pK value itself. Could the pKa value be higher? If there was an inherent pKa value that was higher than the normally reported 12.2 and 12.5, then the arginine would resist the urge to shift down to become deprotonated. This corresponding shift from, say, a pKa of 13.6, which is consistent with guanidinium derivatives that we know of, that would result in a 10 kilocalorie shift in the overall delta G of the protein. This delta G would destabilize the entire protein. This final reason of a higher pKa value was the main reason, or the main source of focus of this study.
Thanks, Micah. Continuing on that thought, there were two methods used in this experiment. The first method was potentiometry used in titration. Now, potentiometry is a measurement of electrical potential in order to determine a concentration. In this titration, potassium hydroxide was used to cause the guanidinium group of the arginine to release its protons. A water lysine blank titration curve was subtracted from the arginine titration curve, shown here, in order to result in a more clearly visible arginine titration curve with three specific inflection points. Now, these certain inflection points represent the three groups on the two amino acids being titrated. The first two are representing the two different aminium groups on the lysine, and the third inflection point at a higher pH is representing the guanidinium group on the arginine. Now, this method of potentiometry determined the pK of arginine to be about 13.8 at a 500 millimolar concentration, shown in table 1. Potentiometry was used because it involves a direct measurement of the protons that are released during the titration. Potentiometry can become unreliable, however, at high pHs because of the alkaline sensitivity of the glass cathode. This source of error was minimized by using a specially designed cathode that can withstand highly alkaline conditions. The titration against the water lysine blank provided a calibration as well as a reference point for fitting the data in equation 1, shown here, revealing the pKa value to be around 13.8. The second method used was NMR. NMR determines the physical and chemical properties of atoms and the molecules they're contained in. Free arginine as well as a tripeptide, a glycine-arginine-glycine chain were used. Now the reason for the glycine in the chain was because of the small side chain would hopefully not interact too much with the arginine side chain. Now, the purpose of the tripeptide was in order to mimic a random protein chain that would be found in a natural environment. The pKa value of the tripeptide was found to be around 13.8. The free arginine was then attached to carbon 13 and nitrogen 15, and the pKa of that was found to be around 13.9. The pKa values are shown in these graphs in bold. These methods support the idea that the pKa of arginine is closer to 14 instead of the usual given value of 12. The NMR is the preferred method for determining protein and polypeptide pKa values. This is because it shows pH-dependent chemical shifts representing ionizable groups. There was a small pKa difference between the free arginine and the tripeptide, and this only shows that the guanidinium group was not significantly disturbed by the presence of the negatively charged alpha carboxylate. This is because of both arginine's long side chain as well as the high ionic strength of a solution with a pH of 14.
Thank you, Hammer. So, in conclusion, through potentiometry and NMR, the arginine pKa value was determined to be between 13.8 and 13.9. This pKa value is significantly higher, almost 2 log units higher than the old, originally thought pKa value for the arginine guanidinium group. This pKa value makes more sense. We know that guanidinium derivatives have a pKa of about 13.6 between 13.8. Therefore, since arginine has a guanidinium group, it would make sense that the pKa value would be roughly in that range, and it was found to be consistent with those findings at 13.8. So what's the importance of having arginine with a new pKa value? With having this pKa value, it makes more sense between the apparent contradiction we seek, or we had seen. By saying that the pKa value was 12.2, that would infer that in physiological conditions, in hydrophobic environments, that the arginine would be found as a neutral species. However, this new pKa value gives us reason to believe and more evidence to back up the findings that arginine is a protonated positive species and makes more sense of those observations. And this is important because this is a unique ability only to arginine. Arginine then can play a vital role in determining a protein's structural stability as well as function. In hydrophobic environments inside a protein, it can be a vital player, especially in enzymatic domains, where a positive charge is needed to stabilize a transition state of a bound substrate. With having that positive charge, it allows the substrate to be bound and therefore acted upon by the protein. And this ability, again, is unique to arginine. Because of the pKa value, the energetic penalty, as we were saying, for a shift from the new pKa value down to the pKa value acceptable for deprotonation will result in a destabilizing force of 10 kilocalories per mole. This force has to be accounted for because arginine is going to want to deprotonate. Due to having a positive charge and unfavorable interactions, it's going to want to deprotonate. However, that deprotonation will destabilize the entire protein complex. Therefore, the energetic penalty is overcome again by the guanidinium group. The guanidinium group can participate in a large number of non-covalent interactions that account and pay for this energetic penalty up front. So, arginine and this pKa value visited. Conclusion, the pKa value is indeed higher. Thank you for joining.